हेलो एवरीवन। ये वीडियो एक जनरल माइक्रो प्रोसेसर के इंटरनल आर्किटेक्चर के ऊपर है। द पार्ट्स ऑफ जनरल माइक्रो प्रोसेसर, द मेन पार्ट्स आर जनरल पर्पस registers, which are B, C, D, E, H, L as shown in the diagram, and stack pointer and program counter. इसमें से जो जनरल पर्पस रजिस्टर हैं वो बी सी डी ई एच एल ये 8 बिट्स के रजिस्टर्स हैं, और डब्ल्यू एंड जेड डजेंट फॉल्स इन द जनरल पर्पस रजिस्टर। ये जनरल पर्पस रजिस्टर्स में नहीं आते हैं। दे आर स्पेशल पर्पस रजिस्टर that are used to store the temporary data in between the execution of particular assembly language program. Then there is a second main part, accumulator, which is a 8-bit register which stores the result of every arithmetic or logic operation. Then there is a temporary register which is 8-bit register that holds the data temporarily generated meanwhile the execution of a program. Then there is a flags. There are 5 flags in a basic microprocessor or 8085 microprocessor. These 5 flags are sign flag, parity flag, auxiliary carry flag, zero flag, and one more is there. Then there is a instruction register which stores the particular instruction under execution. Then there is arithmetic and logic unit which performs the arithmetic and logic operation. Remember that in addition with the arithmetic operations, that is your addition, subtraction, multiplication, it also performs the logic operation, and logic operations are and, or, not, and XOR, out of which XOR is the main logic operation. Then there is a timing and control unit. Timing and control unit provides the timing signals and control signals to the microprocessor. The X1 X2 is a LC latch. In fact, L is, as in the first year electronics, you have read the LC latch. L stands for the your C stands for the capacitor, and L stands for the inductor. Inductor, I'm not sure, but L stands for the inductor. It is a LC latch which generates the clock frequency required for the microprocessor. Then there is a CLK out. This is clock out. Then there is a ready signal. This is an input signal to the microprocessor, which represents that a slow responding peripheral device is ready to receive or transmit the data. You can understand it in this way that a microprocessor is a very fast processing electronics device which operates on almost 2.6 gigahertz speed, and the peripheral device means input output device, your keyboard and mouse and printer and scanner, which are very slow responding device in comparison with the microprocessor. So these peripheral devices will send a signal ready to the microprocessor that now we are ready to accept or transmit the data to the microprocessor. Then read and write control signals RD bar and WR bar. On whatever signal there is a bar, it is active low signal. In microprocessor subject, specifically in the microprocessor subject, on whatever signal there is a bar, it is active low signal. That means when we will give the 0 to that signal, then this signal will work. If we will give the 1 to the at this signal, then this signal will not work. So the RD bar and WR bar are active low signal. RD bar represents that the read operation is going to perform, and the WR bar represents that write operation is going to be performed. Means read means that the microprocessor is going to read the data from the memory, and WR means microprocessor is going to write the data on the memory. Then there is a ALE signal. This is address latch enable signal. What it does, ALE signal is used to latch the address and data bus. In 8085 microprocessor, you know that there is a 16-bit address bus, out of which there is a 80 to 87, which is a low order address bus, which is used for the two purpose, that is for the data and the address. And there is A8 to A15, which is used only for the high order address. So on a low order address bus 80 to 87, when we will use the address, when we will use it as the address bus, and when we will use it as the data bus, it is bifurcated by the ALE signal. When ALE signal, you can see that it is a active high signal. It is active high signal. That means when we will provide 1 on this signal, then this signal will work. And when this signal will work, then on the 80 to 87 address will be transmitted from the microprocessor. You can see the name address latch enable. लैच आप जैसे लैच एक डोर में लैच होती है कि लैच को हम लोग ओपन करेंगे तो समवन कैन इन और आउट, दैट इज़ द फंक्शन ऑफ लैच. आपके कमरे में एक डोर है, उसमें एक लैच है, आप लैच को ओपन करेंगे तो कोई बाहर जा सकता है, नहीं तो नहीं जा सकता है. सो दैट्स द सेम वे कि ALE सिग्नल को हम एक्टिवेट करेंगे. व्हेन वी विल एक्टिवेट द ALE सिग्नल, then address can be transferred on 80 to 87, and including to this also on the A8 to A15, combining this all, that will make the 16-bit memory address in the case of 8085 microprocessor. Then there is these are the state, then there are status signals, S0 and S1. S0, S1 are the status signal. These represents the state of a particular microprocessor, that in which state microprocessor is working. S0 S1 को एज अ कॉम्बिनेशन हम लेते हैं. जैसे आपके एंड गेट और गेट की टेबल्स में एक्स वाई एंड आउटपुट होता था. फॉर एग्ज़ाम्पल यू कैन अज्यूम कि आपके एंड गेट की टेबल में एक्स वाई और आउटपुट एफ इक्वल्स टू एक्स डॉट वाई होता था. तो उसमें कॉम्बिनेशन बनते थे दो वेरिएबल्स के कॉम्बिनेशन 0 0 0 1 1 0 1 1 चार कॉम्बिनेशन बनते थे दो वेरिएबल्स के. उसी तरह से S0 S1 ये दो वेरिएबल्स या दो स्टेटस सिग्नल हैं, इनके टोटल चार कॉम्बिनेशन बनेंगे 0 0 0 1 1 0 एंड 1 1. So on certain combination will represent the certain state of the microprocessor. Then there is IO slash M bar signal. This signal is also used for the dual purpose. When this signal is active high, then it represents that some input output operation is occurring, and when this signal is active low, then some memory operation is occurring. Then there are DMA signals, hold and HLDA. DMA is direct memory access. DMA means direct memory access. You know that what DMA works. If through DMA we transfer the data from memory directly to the peripherals without the interference of microprocessor. So hold and HLDA are the DMA signals. Now I am going in the brief, either the video will be too long. There are a reset in signal which resets the microprocessor to the initial state. A reset out, it resets the peripheral devices. And then a stack pointer, we go on the stack pointer, which is 16. Stack pointer holds the 16-bit memory address of top of the stack. Stack will hold the pile of data, and stack pointer will hold the uh, memory address of top of the stack. Program counter is a 16-bit memory address, and this 16-bit memory address will hold the address of next instruction under the execution. Then there is an increment and decrement address latch through which we will increment or decrement the memory address. Then you can see that there are two address buffers. Address buffer, first is 8-bit, second is 8-bit. First, it represents the A8 to A15, that is high order address bus, and 80 to 87, which is a low order address slash data bus. We say it address slash data bus because address and data both can be transmitted through this bus. So what is left? ALU, flags, instruction register, instruction decoder, and machine cycle encoding. So the instruction register will hold the current instruction under execution instruction, and that instruction will be in assembly language. You know the assembly language, you know the instructions like MOV A comma B, which will transfer the data of register B to the accumulator. MOV A comma B, A is accumulator and B is register B. So the content of B will move to the accumulator. This is the assembly language instruction MOVB of the 8085. So suppose the instruction register holds this instruction. So this is in assembly language. Instruction decoder will decode this instruction, that what operation will be performed by this instruction. And machine cycle encoding, at this step, machine cycle encoding, assembly language instruction will be converted to the binary format, that is the 01, which will be understood by the microprocessor. Then there is you can also see there is a multiplexer on the all registers, that is W, Z, B, C, D, E, H, L. Remember that it is compulsory to write the size of registers, that is 8-bit or 16-bit, in the diagram. What is the purpose of multiplexer? When we are going to use the B, C or D, E or H, L register as a whole in combination, then the multiplexer is used. That's mux. Then there is also register select. Register select selects the through it we can select the particular register. Then what is left? The green bar, whatever the green bar is there, it is system bus. It is system bus through which the address and data and control signals are transferring, through which control signals and data and address are transferring to and from the many blocks, many building blocks of the microprocessor. Then you can see that there is a interrupt control. What is the interrupt? Interrupt is a particular signal which is when given to the microprocessor, and the microprocessor halts its current operation under execution and executes the interrupt subroutine, the routine given by the interrupt. There are total 5 interrupts, that is the INTR. There are 5 interrupts, INTR and RST 5.5, RST 6.5 and RST 7.5, out of and trap, out of which trap is non-maskable interrupt, and rest INTR, RST 5.5, RST 6.5 and RST 7.5 are maskable interrupts. What is the difference between the maskable and non-maskable interrupts. We can avoid the maskable. We cannot avoid. We can avoid. Sorry for discontinuity. We can avoid the interrupts. We can avoid the maskable interrupts by somehow. We can avoid the maskable interrupts by somehow. So the INTR, RST 5.5, RST 6.5 and 7.5 are maskable interrupts. We can avoid them by somehow, by some signals. But trap is non-maskable interrupts. We cannot, microprocessor cannot avoid the trap interrupt. INTA is not an interrupt. INTA bar is not an interrupt. It is an acknowledgement signal that yes, microprocessor is entertaining the interrupt signal. SOD and SID are two signals, serial input data and serial output data. These are the 1-bit signals. Through SID, 1-bit data or control can be given to the microprocessor. 1-bit data of any kind. I will say that 1-bit data of any kind can be given to the microprocessor, and through SOD, microprocessor can output 1-bit data of any type, any kind. So these are the serial input output controls. So this all is the building block of the microprocessor. As per in the subject of 8085 microprocessor, the internal architecture, explanation of the internal architecture of 8085 is very important. And when we will write the main building blocks of the 8085 microprocessor, so first comes the GPR, general purpose register, then the second is stack pointer, third is program counter, and then fourth is accumulator, then fifth is arithmetic and logic unit, sixth is instruction register, then seventh is timing control unit, and eighth is interrupt control, and ninth is serial input output control. When we write the answer and flags flip flops, which are 5 flip flops, 5 flags are there, and flags represent the status of result. Flags represents the status of result. There is sign flag, carry flag, parity flag, and auxiliary carry flag and zero flag. Yes, now I can recall the all 5 flags. Sign flag represents that whether the result is negative or positive. Carry flag represents that the whether carry is generated from the result. Then parity flag represents that the parity of result is even or odd. Then auxiliary carry flag represents that the lower nibble is a 4-bit of the data, that so the auxiliary carry represents that the lower nibble have generated a particular carry or not. This is a tricky one. Then zero flag represents that the when zero flag is 1, it represents the result is 0. Instruction decoder and machine cycle and temporary register and multiplexer and register select and W and Z register. These are not in the main building block of the 8085. 8085 and the main building blocks of the 8085 are 9. Thank you.